Good morning to everyone. My name is Ben Ojosrochi Hueze. I'm here to give a presentation which was written by Mohammed Forward on the categories of artificial lighting system. One of the categories is light emitting diode, known as LED. Description: a LED light is a semiconductor light source that emits light through current flows through it. When current flows through it, electrons in the semiconductor recombine with electron holes, releasing energy in the form of photons. Purpose: appearing as a practical electronic component in 1962, the earliest LED emitted light intensity infrared light. Infrared LED are used in the remote control cycles, such as those use a wide variety of consumer electronics. The first visible LED light were very low intensity and limited to red. In this modern LED, there is availability across the visibility with ultraviolet and infrared wavelengths, which of high light output with different colors. The basic effect: LED have the advantage over fluorescence lamps in that they do not contain much mercury. They contain more of hazardous metals such as lead and arsenic. One of these advantages of LED light is that this LED, light emitting diode, being a solid state component, they are very difficult and hard to damage because they have some external shock, unlike the fluorescence and the incandescence bulb, which are very weak and easy to damage. In fact, literally, they would say they are very fragile. So, when looking at some of the disadvantages or the problem of the light emitting diode, which is literally known as LED, LED must be supplied with a voltage above their threshold voltage with a current below their rating. Current and the lifetime changes greatly with a small change in the applied voltage. The next one is electric discharge lamp, which was written by Asif and as well presented by me, Ben Ihweze. When we talk about electric discharge lamp, it's according to Asif, it is also called like a vapor lamp. It's like a lighting device consisting of a transparent container within which a gas is energized by an applied voltage and thereby made to glow. According to a French astronomer, Jean Packard, who observed this in the 1975, he said it's like a faint glow in the mercury barometer tube when it was initially agitated. But the cause of this glow, which is electric static, was not actually understood as of this time. So in the year 1855, there was a glacier tube in which a gas at a very low temperature glow was subjected to an electrical voltage. This principle actually demonstrated the electric discharge lamp. So after some practical generators, some science researchers, observers were put in place and devised this in the 19th century. Many experimenters applied electric power to tube of gas. So from 1900, there was a practical electric discharge lamp that was in use in the late European countries and the United States of America. So actually also a French inventor by name Jodis Claude, he was the first to use this neon gas about 1910. So this mercury vapor is a new lamp. It's like a new lamp that gives a bluish light. So mercury light is actually used also in a fluorescence lamps and some ultraviolet lamps. So helium, as we know, is an amber gas that glows in that often glows in gold color. Blue light, the blue light in yellow glass that shows, but sometimes shows green as well. So combinations of these gases give us white light. So the sodium vapor lamp, which was developed in 1931 in Europe, is a good example of this illuminant, because it tries to illuminate very shiny if the yellow color of is widely acceptable or globally acceptable. So this glow lamp I'm talking about is actually used as an indicator or as a night lamp, as most people use as their night light. It contains a high resistance filament in a small bulb. So this voltage differences between plates at the end of this filament causes the enclosed gas, usually neon or argon, to identify, to glow faintly, not like so bright, very faintly. So it uses little power but lasts longer. So because of the glow, discharge tends to keep the voltage across the lamp constant. It is sometimes used also as a voltage regulator. So we look at the main purpose of this electric discharge lamp. So electric actually power discharge lamp generate light by passing some electric arc through a space full of special mixture of gases. So in contrast to the incandescent lamps, electric discharge lamp cannot be operated immediately from a power deliver. No. So sometimes they require a ballast that controls it from the beginning, and its operation acts as a present day, prescribing about a device to 10 to 15% of the energy utilized by an electric discharge lighting features machine. So this add up in the ballast and are giving off a heat ballast that are rated by the way of the operating temperatures. So sort of this overheating protection and noise level in the recent trend in the ballast layout have blanketed the improvement of electronic ballast that consume up to 20 to 25% less than general ballast, which might offer a dimming capability. So let's take a look at on the effects of this electric discharge lamp. Number one, the color of the light varies. It actually varies with the phosphor coating. The initial cost of installation is maximum, but running cost is very, very low. So since the stroboscopic effect is present, they are suitable for semi-directing lighting, domestic, industrial, commercial, road, and so on. So secondly, change in voltage also affect their starting. So although lighting output does not change, it doesn't change as remarkably as in the case of incandescent lamps, but color of their light changes with a different phosphor. You get the point? So coating on the inner of the tube. The next one is the frequent switching. The frequent switching of these electric discharge lamps, frequent switching, do affect their lifespan period. They are very quite in their high utility, but their voltage rating is very, very low. Lastly, as a stroboscopic effect, they have an average working life of about 4,000 hours, and they're very, very luminous efficiency of about 40 hours. So because they are alternating natures of supply, it crosses 0 2 times in cycle for the 50 hours supply of alternating current. So a discharge lamp will be distinguished twice in a cycle and 100 times per second. Like our human eye cannot easily identify this extinguished phenomenon. Why? Because of the persistence of our vision when looking at this. Okay, so this can easily be called, or this effect can easily be called a stroboscopic effect. This effect can be avoided. It can be avoided by applying any of the following techniques, which I will tell you. So if, for instance, if you have a three-phase supply, Then the fluorescence light that are adjacent should be fed from different faces. Don't face directly to your face. So next one is when you have when you have two lamps, so it's not advised wisely to be placed at the same zero instance of the AC supply. So light present at any instance, if this supply is in a single phase, then there will be a twin tube circuitry that can be employed so that the stroboscopic effect will definitely be eliminated or not be much be ineffective entirely. So we're looking at the advantages or the benefits or the importance of this electric discharge lamp. One is the heat is relatively low. Two, it is energy efficient. Three, it ranges from low to high grade. The fourth one is the long life, so it have a long span of staying, more durability. So the last one is usually in a cool source, not much heat is involved. So we look at the disadvantages of or the problems of this electric discharge lamp according to Asif. He said number one is they have a color temperatures. Okay. Two, it requires ballast. That is something that you just need to start it. So it's like a preheat or an instant supply, more or less like a rapid start. Once you just on it to start. So one of the problems have. The third one he said is it requires a controlling element. It requires control element for its glow control. The last he said each light contains a mercury that can be harmful for both human and wild. The next is conventional lamp or conventional lighting, which was written by Zahab. So according to Zahab, he said when we talk about conventional lighting or lamp, we are typically referring to halogen lamps and high intensity discharge lamps. Although it is actually old-fashioned when compared to the new fragrant LED light, conventional lighting remains popular. It's because of its large output and low cost. So its brightness and affordability is always come at a cost. However, conventional lighting or conventional lamps consume far more energy than the LED stage lighting, making it extremely inefficient. The features produces more of a lot of heat as well, and the hot equipment can be difficult to handle and manage. Finally, because they live a significantly shorter lifespan, so the conventional features sometimes is often replaced and repurchased more or less. So if you are dread of the maintenance and often being frustrated using this burnt light, you may wish to transit to the LED light, which is the newly and the modern features light of today. So this conventional lighting rod, which according to spike arrestor, or you call it lighting conductor, is like a metal rod or a conductor mounted on top of a building, and is electrically connected to the ground through a wire or 18 copper stripes to protect the building in the event of a lightning strike, thunder strike. So if thunder or lightning strikes the building, then according to the laws of physics, it will preferentially strike the lighting protection, rod in lock now, and this can be conducted harmlessly, that's causing less damage or non-damage to the ground through the wire. So instead of passing through the building where it can start a fire or cause electrocution, so a conventional spike lighting protection rod is like a single component in the lighting protection system. In such a system, the lighting protection rod lock now are placed at regular intervals on the highest proportion of a building. So this lighting protection system typically include a rooftop network of electrical conductors, multiple conductive paths through the roof to the ground earthing. This is bonding the connection to a metallic object within the structure and an earthing grounding network. So the rooftop lighting rod is a metal stripe of a rod usually made of copper, aluminum, parts, damp parts, or it's even made of like GI stripes or wires, coppers and aluminum. So we have some principles of component of this LPI flat type conventional lighting or conventional light protection system. They include: one is air termination network. The primary function of an air terminal or air termination network is to capture the lighting strike to a preferred point, so as to ensure that the discharge current can be safely directed via the down conductors, which was buried in the ground, to the dedicated emitting system. So the next one, or the number two, is the down conductors. The purpose of a down conductor is to provide a low impedance from the air termination to the emitting system, so that the lighting currents can be easily conducted to earth without developing much or excessively large voltages. So you talk about number three principle is the earthing system. Each down conductor must have an earthing system with a provision made for this disconnection of each down conductor from the earthing system for testing purposes or installation purposes. So the last one is what they call the bonding to avoid side flashing. It is highly recommended that all mental work, including